Problem number 4 is a problem of an application. We're going to use Desmos to graph it. So the first thing I'm going to do is I'm going to type everything after the equals into Desmos, and I'm going to graph the equation. And when I graph it, I should get something that looks like this. I'm just labeling our important points here. Okay, so it says a toy rocket is launched vertically upward from the ground level with an initial velocity of 128 feet per second. Then its height h after 2 seconds is given by this equation. How long will it take for the rocket to hit its maximum height? But here at the vertex is what we're going to use for this. Our maximum height is 256 feet, and it happens at 4 seconds. So this actually answers part A and part B, because part B is asking us for the maximum height, not when it hits the maximum height. So there's our 256 feet. How long does it take for the rocket to reach the ground? Well, it launched from 0 feet, it goes up, it comes back down, and then it lands again at 8 seconds. So those x-intercepts tell us when it touches the ground. All right. Let's go on to problem number 2. It's very, very similar. We're going to take function f here, and we're going to graph this in Desmos to model the height of a ball 2 seconds after it was thrown. So go ahead and type what I highlighted into Desmos, parentheses 3 minus t, and parentheses 4 plus 16t. When we graph in Desmos, we are going to find the zeros, or the x-intercepts. And we find these at t equals 3 and t equals -4. And we just graphed those in Desmos. What do the zeros tell us in this situation? These are the times that the ball hits the ground. And then it asks if both of our zeros are meaningful. No, they are not. The negative, we can have negative seconds. So I'm going to say it's irrelevant. Because you can't have negative time. From what height is the ball thrown? So if you look for your y-intercept, you'll see that it is thrown at 12 feet. We have a y-intercept of 0, 12. And this is the y-intercept. About when does the ball reach its highest point, and about how high does the ball go? So if we look for our vertex here, let's go to the vertex of our graph. Which is going to be our maximum on our graph, because our graph is concave down. And again, just make sure when you're typing into Desmos, don't use t, use x instead. It does mess it up. So if we find that vertex, it is at 1.375, so 1.375 seconds. Reaches the maximum height of 42.25 feet. And again, we just use the vertex to find that. So now let's do the same thing with these graphing on the next couple problems in the next video.